Hey guys, how's everything going? This is Jaser. This is the fourth video of me walking through the React source code. In the previous video, number 3, we've taken a look at how React to update the fiber tree. So this is the chart. Let's take a brief recap. So when the here. So the code is React useEffect, and the function actually set a timer, and when time is up, the set account is the trigger is triggered, and then the state is updated. So the set account actually dispatch a function, see if the state changes, and then if this changes, it will schedule an update on this fiber. This is the element, and then ensure the root is in schedule and a flush sync callback. And actually, in these steps, there is a perform sync work on root because the state changes. It will the task perform sync work on root is pushed into sync queue, and when everything is the check is done, the flush sync callback queue will trigger all the tasks in the sync queue, and perform sync work on root is triggered. So and in the perform sync on root method, it will do the same as how we construct the fiber tree at the initial mount. It will create a clone of the fiber tree and mark each node if it is changed, if it is needs to be re-rendered or not. As we can see that because we calculate the state, the props, and define that only this fiber text, which originally is 0, now it becomes 1. We need to update it, so we mark it as red. This is the fiber we need to reflect to the DOM. And through the top-down process, we find the change in node, and when in the bottom-up phases, we would connect the first effect and the last effect, and chain all the change nodes into one singly linked list. And then in the commit phase, we would just loop through the effect list, and then just skip all the nodes, just go directly to the change nodes and to reflect the DOM. So this is how we briefly updated the fiber. Now in this video, we would take a look how the useEffect is working. In the previous one, we just start with the set account, right? But actually, the React useEffect, also it is a dependency here. We need to see how the set account is triggered. So this video is about things before this set account. Okay, I'll start a new blank chart. Let me zoom in a little bit, and let's begin. The code is same as before. We have this simple app, and it has a user state initialized to 0. And we use effect and update state to 1, right? Increment it after every 4 seconds. So we reload it, it was 0, and after it's going to be 1, which is updated in the steps we talked about in third video. Now it's just us continuing our usual hacking method. We add a breakpoint to the set effect. Wait a minute, where is it? It should be here. Okay, here. Ooh, I cannot set a effect here. Allow me to update it in the editor. Okay, here, let me set a debugger. Okay, let's go back and then reload. So now this step stops at the debugger here, right? So the useEffect, and this is function. This function is triggered. Let's see the call stack. It's actually the anonymous invoked passive effect create callback invoked. Okay, this is invoke. We could skip it. Flush passive effect implementation. Yeah, this seems to be the function we need to check, right? Actually, let's see. It actually said flush passive effect let's first mark this one, flush, which is flush. What is it? Flush passive effects. From the name, we see that it actually would just seems like caching some effects, which is the function we need to call, and then at last something, and then we trigger them all. And when it is triggered, it will call the run with priority. So it's run with priority. We will skip priority for now because it's related to the lane, I would believe. And flush passive effect implementation. Let's see what it is. In the passive implementation here, yeah, it says root with pending passive income, blah blah blah. Okay, unmount effect. Yeah, it is some effect here, and also we have this mount effects. So this unmounting effect is from the pending passive hook effects amount, and this is pending passive hook effects mount, and it's just gets the effects and then reset it to the empty, right? And then we would trigger all the mount effects. For each effect, it would trigger the callback, invoke the passive effect create, and this is the effect we get, right? This is we trigger it, when it's created, it will get the create and destroy create. Actually, it's be called in the create, I believe, right? Invoke, yeah, it's actually called in the is create. Okay, let's go back to the flush here. Oh, implementation. So there are two arrays we need to take pay attention to. Which one is this one? Pending passive hook effect unmount. It's seems like the okay. I'll put it here because it's not a function. I'll mark it like this. It's a I will believe it's an array or something. Okay, let's make it smaller. And also there is one pending passive hook effects mount. Okay, when the flush passive effect is called, it actually, we can see that mount effect actually here. There are two items in, right? One is a create, which is the method, like, yeah, debugger set timeout, and it has dependencies, which is 0, and also the fiber node in this array. And let's see how it is triggered. Oh yeah, when we loop through the effects list, we're getting two items for each time. The first one is the effect function, and next one is a fiber actually. So we would mark two things in. This is the effect. This is fiber. This is actually not an effect. It's something, some wrapper, I would believe, right? It says a tag and a create. Yeah, let's just put an effect here. I would say effect wrapper. It's a hook. Maybe this is hook. Okay. Fiber. These two. Okay, when flush passive effect is called, these two will be accessed and popped from the array, and then they will be triggered, right? Yeah, will be created with the invoke passive if correct, create, and then we see that this is where our code stops here, anonymous. Yeah, when it is set timeout, and set timeout is called, and after 4 seconds the set count is triggered, which goes here. And this is what we talked in the previous video. So that's it. So flush passive effects, and then let's put the effect. Let's say the effect is something like this. Effect is effect timer to set state, right? This is our custom effect, and this wrapper actually points to this state, to this effect, and then get it. Do something like this, and it will be run, right? Run. Great. And then go. And this is what we get from the first debugger here. Okay, a flush passive effects. Let's dive more from flush passive effects. Where is it from? It's actually from this anonymous function, schedule callback, which is from commitBeforeMutationEffects. Let's see what it is. commitBeforeMutationEffects actually from our React 2 here. We see that there's no 3. Oh, it's not, and it should be in the first one. Sorry, it actually should be the commit phase after the render phase, right? Yeah, let's mark it down. Flash passive here. Okay, flags passive. If there's passive, we would schedule a callback. So I'll say this, add a breakpoint here. Actually, if there's schedule callback, because from the name it's schedule callback, so it should be something stored separately. They're not triggered right away, I believe. Schedule callback, and this is schedule callback. It's in the React development now. Blah blah blah. We set a new task. You see, we set new task, and then request host callback flush work. Push the task into task queue, and the task what callback is? Callback is the flush passive effects, right? Okay, wait a minute. Yeah, flush callback effects. This is the callback, and then callback is wrapped into this new task. Task is pushed into the task queue. So this push, it just by the stack index cursor current. Yeah, we just could think it as an array. Here. Sorry. Oops. Cool. We debug it here. Okay, now we have something new, which is task queue. Oh, I'll move it further. Okay, we have something big as this is the task queue. Okay, vertical. And then in this task queue, we push the new task. New task has a callback of this callback, which is this flush passive effect. So it's in here. Ooh, we move it to front. And this move to front. Okay. Yeah, we push it task queue in this schedule callback. And then let's see what happens. We schedule it, and we request host callback, right? Let's reload it and see schedule callback. Yeah, request callback. Request callback is said report post message here, and port his is new message channel, and the port 1 on messages perform work unit until deadline. Okay, this is something new. We log it. So this, okay, this one. Here is a nice trick that to create a new task faster than the set timeout is actually. So anything synchronously called after this one, after this schedule callback, will be called, and the callback of this on message perform unit work unit deadline will be scheduled in the next event loop, which is faster than the set timeout. So this is a common trick. I will talk about it later. Yeah, so here request callback set. Let's add it here. Set to task queue. Not only this, it will actually also create a new one called schedule new task, which is perform work unit at deadline. It's something this. Okay, I'll create a shape for this one. Perform unique deadline. Remember, this will not be called right away. Okay, this should be delayed to next event loop as a new task with message channel hack. Okay, so schedule this callback is called, and it will continue on the schedule callback. Let's see where it is. Yeah, flush it, and then it's done, right? It's go to the next effect, and it's in the commit before mutation effects. Let's see where this is from. Commit before mutation effects. Schedule callback is in the. Oh, this is a function. Let me create a shape for this. Schedule callback. And then it's in this commit before effects. Okay, so now let's see where this is from. It says callback. Actually, it's in commit root, right? Commit root. Yeah. So we can now see that it's in commit root. In this commit root, let's see what it is. Commit root implementation here. Okay, let's reload it. Okay, now we can see that in this commit root there is mark. Okay, and then blah blah blah. Now we have the first effect. Let's see what it is. It's finished work. Flags is bigger than it. And okay, let's go here. So the first effect actually is the initial mount, so it should be the app. And then what it does, it's commit before mutation effects. Commit before mutation effects here. So yeah, it is called right away. And for all the effects, right? As we see in the third video, the effects is some linked list for all the changed fibers, or the root one for the initial mount. Here the first effect is the app, and then next effect we can see that it's yeah, there's no, it goes to this parent. The child is the app, yeah. And then this next effect is null, now, so stop here. First effect is not now. And yeah, it will commit before mutation effect. It will call it. And let's continue the log here. Commit layout effects, I believe, here. Yeah, this is commit mutation effects. It will recursively call it. So I'll add a new one. Add a new mark like this. And then also schedule callback here. Right? It's in the schedule mutation. Commit. No, it's not commit. It's not here. Commit before mutation effect. Before, and then when it has these effects, it will trigger the passive. Schedule the passive effect. Yeah. So add the. I move it little to the left, and then add a new one. It's this condition. What it is? It's if passive, if has passive, as if passive, right? If it is passive, flags of the effect, passive, and then it will schedule a callback. It will put the flush into the task queue, and it will perform the work until deadline right after every synchronous task is done. Okay, so there are some mystery steps. Okay, here. We need to dig out. First, we list up all the steps in the commitRoot. Okay. commitRoot. We see that there is a commit before mutation effect, and then commit mutation effect. It will get the first effect while loop here, so it will call the another effect is commit mutation effect. This is the actual render face for the DOM, and then it will call the commit layout effects. It will do it over it again. Commit layout effects. This also should be repeat work. Commit layout effects is also repeated work, and then request paint, right? Yeah. Log here. Request paint. Let's see what's in this request paint. Okay, there is nothing here. First effect. This is the app, right? Yeah, passive. This commit layout effect. Request paint. Let's see what it is. It's actually nothing, so it's done. End. So when synchronous thing is done, we see that perform work unit deadline should be called, right? Because it's in the next event loop. Let's set a breakpoint to this one by remove. Okay, I remove this perf here for perform work done. Oh, I remove all the breakpoint here and only set it to the perform work done. Okay, here. Oops. Okay, we can see that it's triggered by post message, which is the message channel. Now let's see what happens in this perform work unit deadline. It has scheduled hostback, time remaining, blah blah blah, port post message. It actually has a way of yield to the host, because it says if there's no time to do, we would trigger it one more time, right? So wait for the next event loop. Okay, we can skip here. Schedule hostback is not null. Deadline, okay, has more work. schedule host back. This is the host back actually. Schedule host back, where is it? We see that scheduled host back. Oh, it's nothing, nowhere to be found. Let's see, where is it set? Request host callback. So when it is triggered, this one, it also sets the another one is scheduled host callback. It would be the what it is, the callback. This is the, I believe it's the flush, right? Yeah. Oh no, it's flush work. What's it? What is it? Schedule callback. Request callback here. Flush work. What is flush work? Flush work is something gets. Okay. So the schedule callback is now set to flush work. Okay, in the flush work, it will run the work loop. Ooh, something. Perform work unit deadline. This is in the, yeah, this is the pushed new task, and then we get the scheduled host. It's a flush work, so it will actually perform the scheduled host back flush work here. Okay, get it, and then it will trigger it flush work. Oh, cool. So it will get here flush work, and let's see what it is. It will return a work loop. Wait a minute. Okay, flush work. Oh, this is enable profiling, and then here work loop, right? We have met the work sync loop, right? And let's see what's the work loop here yet. It will current task, pick the task queue. It will work loop flush work. It will trigger the work loop. The task is pick the task queue. Task queue is here, yeah. And then blah blah blah. Go back. It will trigger it, right? Because it's a task callback. Here, flush passive effect is a function, so it will trigger it. Oh no. Work loop. Current task is not now. Let's see. Flush work. Because we stop for too much time, it yields for the host. So the actually, okay, this might yield to host. This is for the something called improve the UX, right? Stop freezing the window. So let's make it faster. Okay, this work. Okay, it's called. Oh, it's too fast. This is tricky. Let's only. Okay, let's remove all the breakpoints and only set it here. If it's callback here. Okay. Yeah, we got it. It's callback now. So it is the callback is the callback. The flush passive listener. Anonymous. Yeah, this is passive. It's called now. Okay, work loop, and it will repeatedly do itself. And also, it will go to the task queue. and flush the passive effects, and it will get the effects from the to list and trigger them. Okay, trigger the effects at timer. So they are, we sort of get things straight. There are still some mystery left. One, how the passive decided, right? Another thing is here how these pending passive hook mount is updated. The passive, let's go back to commit before mutation effect. Come back to commit before mutation effect. We see that actually we're checking the flags. The flags are from the effect, right? Which in the video 3, which the change nodes or the root nodes for the initial mount. So it should be determined in the render phase before the commitRoot, because here we're checking each effect, which is each fiber, right? So it must be something in the rendering phase. Allow me to zoom in a bit. Okay. When the render phase is done, we come to the commit phase, and in the render phase, we will create the initial fiber tree or create a clone of the updated fiber tree. And so to see how the flags is working, we go back to our initial breakpoint here and add a debugger to the useEffect. Let's see what happens here. So this useEffect is called when our app is called. Our app is called in the initial mount or constructing fiber tree, or during the reconciliation, right? Reconciliation process. Okay. Wait a minute, where we are? Yeah, here. App. So it says it's render with hooks. Yes, component is called, and the mount indeterminate component, and it is called with the render with hooks, and begin work. It says working progress tag indeterminate component. Let's add a breakpoint here. Work in progress, it's the no child. Yeah, it's okay, wait a minute. In our app, the app itself is a function component. The parent of it, it's nothing, right? So its tag is 3. It's not here. 3 actually is host root. Yeah. And let's see another one. It's begin work. Now it's 2. It's in yeah, because for function component there is no why is not function component? Work in progress tag interminate component. We would come back to this later. For now, we will just see that it calls this mount indeterminate component. And then we have this render with hooks being called, right? Yeah, being render with hooks be called, and apps is called to create the element, and useEffect is called. And let's see what the useEffect is. It's at useEffect, and actually there is a mount effect. Go to mount effect, and the mount effect implementation. Yeah, we find out currently rendering fiber flags is set to fiber flags, which is the passive. Yeah, 516. So it says this the current fiber is app when constructing the node, and the effect is push the update queue. So this mount effect actually is the real one to update. Okay, wait a minute. Mount effect. Okay, let's say this is a fiber dot flags. The the passive will check the flags, and the flags yeah, oh, I will put it here. This is better. Okay, the flags will be set with mount effect for the initial one. This is render phase, and yeah. And then it's set to the passive, and then before mutation commit, it sees that the passive is true, and then you schedule a callback, and the flush passive effect is set. It's just the initial trender. When there's another passive, we can see that in the commit before mutation effect, it actually set the flag, right? Root, if it says it's true, it will not schedule twice. So for multiple one, it will schedule only one. So this is obviously debouncing. Okay, so yeah, let's see what happens if it is for the update. Let's set a timer, a break, stop the code when the second update happens. Let's see, work progress. We skip it. We see that useEffect is called again, by which actually is in the update function component, which is in the begin work. The work progress here tag is 0 function component, because in the second render the state changes and it's the tag becomes reconciling, not the initial mount, right? It's not reconstructing but checking the difference. So we see the update function component here, update function component type blah blah blah. Okay, and it calls the render with hooks. Still render with hooks. And let's continue. It's called again. Oh. No, we should log useEffect here. Wait a minute. Okay, log it. Yeah, update function component, render with hooks. Yeah, render with hooks. And then we call the component. Component is called, no, why this is triggered? Wait a minute. Okay. Component is called useEffect. Oh yeah, useEffect is called again. We call the useEffect here. And now it's update effect now. Update effect now. It's in the hooks dispatcher update inf. Okay, we will come back to it later. For now, we see that it's in the update effect. Update effects. To update effect implementation. So here we see that it will check the preview effect is memoir states, and it will compare that hooks inputs are equal. If it is not equal, if it's not equal, we set to the update passive here. If it is equal, there's nothing we need to update. So we just push the effect with hook flag. Hook flag has effect with 1 and not, right? So there is also these update effect, useEffect, which is update effect. We'll also set the flag. They have different flags here. They have different flags here, which okay. dispatch action. When the dispatch action is set, wait. Where this is called? When the first one is called is actually is mount effect, right? Let's see. Yeah, it's mount effect. Now it, for the second one, it actually becomes the update effect. Even for the same React use effect. Resolve dispatcher. Let's see what is this. React current dispatcher current. It must be set with someone else. It's here. Ooh. Oh yeah, here. Paris dispatcher. Anyway, we would dive into the details in the future. For now, we see that the mount effect for initial mount and for the update effect will update the flags for the fiber where they are processing, and in the commit before mutation effects, they're checking the flags and see that if it has the passive effect or not. Yeah, when it is true, it will set the flush callback in the task queue. So this is it. In the render phase, we update the flags, and in a commit before mutation, we set the callback. And so last step is how these effects are pushed into this pending passive hook effect mount array, right? Let's just search it. We immediately found that the push here. Let's log it down. Okay, here. Yeah, we remove all the breakpoints and just set this one. Okay, this is called in a schedule passive effects, and commit life cycles, commit layout effects. Commit layout effects is commit the root. So commit layout effects here. Yeah. So actually in these layout effects, we will commit lifecycle methods. Commit life cycles. We link it, and in these life cycles, we see that wait a minute. Yeah, the finished work. The tag is 0 is function here. So commit hooks list mount. This one, schedule passive effects. Schedule passive effects, it will enqueue the pending passive and enqueue the passive hook effect mount and unmount. So there is a new task here, which is schedule passive effects. Commit, okay, here. Schedule passive effect list. This is finished work, this is the app. So this is called, and when this is scheduled, this will push the effects. These effects should be from the update queue, right? Yeah, update queue get from there. As the hook list actually. the hook list and push them into this two. And also here. And then all the hooks are when in the initial mount is done, the hooks will be in in this list. And when the request bit is called and everything ends, it will perform a work loop and flush it, and effects will be put out from the queue and then trigger them. So to make this more clearer, we modify our code a little bit, and the log here, which is the flush passive effect. Okay, flush passive effects. Remove all the breakpoints, only set here, and we alter our code by creating another component, function counter, count, return, this is b span count. So we remove the count here by a count component count, and also we add a hook here, react useEffect. When the count changes, we would trigger it. So console log effect in counter here, debugger effect in app. Okay, let's reload it. Now we flush. Oh, this is the one. Okay, here and also here. Okay, so for the initial render, let's see what it is. The hooks on mount, we have 4. Actually, there are 2 nodes for one hook, so there are there are two hooks. Because we're in the third video, we know that it's top down and then bottom up to connect the last effect and first effect, right? We can see the mount effect is, the first one is what is it? It's the bottom and then the top, right? Yeah, so that changed like this. The first effect is in the bottom, and then next one is to the parent. And also, this stands for the mount effect. The mount, the first one is the smaller one, the child one, the effect in the counter, the depth is 0, and the second one is the root, is the app. Let's log it. Effects in the counter, effects in the app. Again, when 4 seconds later, this will be run again. Let's see the pending passive hook amount is just the same. Yeah, right. It's just for the child, and this is for the parent. So that's all. We've now know how the effects are collected and into this array, and also how the task of flushing these effects are scheduled by checking the flags. Check out commit life cycles schedule passive effect. Yeah, because in the layout effect, you already know that it only checks the changed fiber nodes, right? So for that fiber nodes, we would only need to collect the hooks of them. Yeah. So there's another mystery. So how did React know that the counter should be in the effect list? Let's say here. It actually just only know that the depth changes, right, for this component. Let's see the log here. We just commit root okay, here we get the first effect should be here. We get the first effect. We see first effect is the span. This is the child. Okay, the next effect here is the app, right? Yeah, if there is no this useEffects stuff, let's see. Here it is. No useEffect. Let's see what happens. Now the first effect is the app. So depending on whether the useEffect is not, we have different effect lists. When the useEffect is used, it will add a new one. It will be treated as the something might change. Something might change, and it will be added to the effect list. If it is not used at all, like this one, if it's like this, then it possibly won't change, and the changes will be determined by its parent. In the app counter, there's no need to check counter separately. This is something very important. So how did it do it? I think it's in something between when determine it is changed or not in the reconciliation. I think it should be something in the in our third video when they are changing the effects. It actually is in the complete work, right? Complete. Help you remember completeUnitOfWork. Yeah, here. Yeah, we can see that in here it will chain up all the effects. Okay, now this return fiber is the button, nothing special. Return fiber is the counter. Flags, complete work of flags. The flags. Now the complete work is the span. Flag 0, nothing. Now this is the counter. Counter in our case here, it has nothing special, so the flag shouldn't be. It's only 1, so it's not big. Nothing. It is not adding the effect. You see, even for the even for the counter. Now if we change it to useEffect, it will be something different. Button, okay, we skip it. Counter. Now let's pay attention. Flag is oh, this is span. Okay, I'm sorry. We should check the complete work, not the return fiber. Yeah, this is return complete. Okay, flag is bigger, right? It's bigger than 1, so it's bigger than 1. It will be added to the effect list now. Return fiber. Return fiber is the button. The return fiber. Return is the button. Why? Oh yeah, it's because it's in the button. I'm so sorry. Yeah, so you see that the counter is added in the effect list. now the all the components with the useEffect used will be added to the effect ist, and also there will be the life cycles their hooks will be committed. It will be scheduled and pushed into the pending passive hook commands effect. They actually should be the same. Yeah, and then when everything is done, the performant unique deadline will be triggered by the message channel, the hack to trigger the task faster than the set timeout, and it finally triggered. As effect function is called, timer is set up. When time is up, set state will be triggered, which goes up to our explanation in the third video. Everything is repeated. So that's it. That's all for our work by to understand how the useEffect is working. I've learned a lot. I hope it helps. This video helps, and there are still some details we haven't covered yet, but I believe that we will dig them more up. So till now, I would say that in React, the source code, the queue, the stack, this recursion, those linked list are all basic algorithm concept. I would say. So it's very important to practice your algorithm skills. For front end, there's no need to practice the red black tree, some super complex algorithms, but the basic one, like the list here, single list here, like the queue here, right? Like the repeated task here. Yeah, it's super important. Yeah, let's try to learn more. And in the following videos, I will believe that we will go to take a look at how we yield the host. Meaning, we already seen a case here. React use message channel hack to create a new task, right here, and here it says it delays the next event loop has a new task. Oh, I'm sorry, not here. And when when perform work until deadline, we see that if we set the timer, set the breakpoint and wait a little longer, it will be infinite loop. It's because when time is up, the React will yield the control to the host. So it says might yield to the host, so we will see how it will yield. So this is very important to, I believe that related to the concurrent mode. So I React try to prioritize all the tasks and checking on the time to make the UX better. Stop freezing the freezing the window. Yeah, I think it's also related to all those lane stuff, right? We've seen a lot of sync lane or the callback lane, something lane. Okay. Anyway, it's all about prioritize tasks. See you next time. Bye bye. Stay tuned.